about the derivative, what comes to mind? Let's get some hands on this. I say derivative, what comes to mind?
Slope of the tangent line.
Slope of the tangent line comes to mind. What else? F prime of x hopefully comes to mind. So I heard like slope of tangent. I agree. I heard F prime of x. I hope there are some formulas that come to mind. These are not things you necessarily need to write down right now. But there are 3 formulas that you need to know. Who's got one of them for me? Let's get some hands on this. Don't call it out. There's 3 formulas for finding the derivative. 2 of them we've used a lot. 1 of them you just need to know it exists. Derivative. Slope of tangent line. Celeste, how you doing there?
Here. Limit as x approaches a.
Limit as x approaches a.
F of x minus f of a over x minus a.
Over x minus a. This guy here is slope of secant. It becomes slope of tangent when we let those 2 points get closer, 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 closer. So this gives you my favorite tan at x equals a. That is one really handy formula. There's 2 more. Stephen.
Limit of as h approaches 0.
Limit as h approaches 0.
F times.
Not f times.
F parentheses a plus h.
A plus h
Minus f of a.
minus f of a
Over h.
over h. This also is going to tell you tan at x equals a. There's one more. One really powerful formula that you need to know. Powerful because it's the thing that tells you the slope of the tangent line everywhere. This was like that second free response question, part A maybe? David, you remember? What's the other one?
Limit of h as h approaches 0.
Limit as h approaches 0.
F of x plus h
F of x plus h minus f of x all over h. Yeah, let's just call that your late happy birthday present. All right. So the difference is the first 2 are going to tell you slope of tangent line at one little point. Your answer is going to be a number. In each case, tan at x equals a. This last one here is going to give you a function. It's going to give you something normally in terms of x. Depending on the question, you might want to go with the third one. Or you might want to go with the first 2. For example, the free response part of the test, what was the question that I asked? It was the second free response question. Package. Second free response question, using the definition of the derivative, prove that f prime of -1 is equal to 2. That's an example of I want to show the derivative at like one particular point. Either of those first 2 would work really, really well. Some people decided to go with the third version. You got like a function answer, and then like you plugged in -1. That works too. That's absolutely fine. What we're going to do is I want to give you guys a little bit of practice here. There are 7 functions. All 7 of them we're going to work through because I want you guys to be able to find the derivative, the general derivative, the function derivative. Stephen, we are getting ready for shortcuts to rain down from the sky. Your derivative process is going to get really good today. But you have to go the way of pain one more time. One more time. I didn't say last day. One more time. Okay. So for those of you that are kind of feeling like, you know what, I just need some practice with the basics, I want you to try number 1 or number 2. If you're up for a little bit more of a challenge, let's call this the spicy level, to try problems 3, 4, or 5. Doesn't matter to me which one. If you want to go for like the spiciest option that's out there, try 6 or 7. Okay? You get about 5 minutes. Show me what you can do. I am going to work through number 7 up here, so the North Central friends, if you just want to stay along with me, that's great. But choose either 1 or 2, either 3, 4, or 5, 6 or 7? Where are the folks that are doing 1 or 2? There shouldn't be too many, but David, okay? David, which one do you want to take?
2.
2. All right, where are the folks picking 3, 4, 5? All right, let's have Aaron and Myra, can you guys do number 3? Celeste, Ale, can you do number 4? And Giselle, can you do, Giselle and Celeste, you guys do number 5. If you need to move, and, Carmen, sorry. If you guys need to move and sit together, that's fine. Friends back here, we're on 3, 4, 5? Okay, so Andrew, I want you to do number 4. Lewis, I want you to do number 5. Anybody doing 6 or 7? Nice, way to get in there. Stephen, why don't you take number 6, I'll take number 7. We'll talk in 5. Help each other out. Shortcuts are coming. All right, I'm going to hang out with the North Central kids.
Right?
Yeah.
All right, so for my friends at North Central, we're working on number 7 here. F prime of x is going to be limit as h approaches 0, f of x plus h minus f of x all over h. Since f of x is 1 over the square root of x, when I do my replacement, we're going to say limit as h approaches 0, 1 over the square root of x plus h minus 1 over the square root of x all over h. Right? Didn't do anything other than replace the x plus h in here, replace the x in there. Now I've got a fraction minus a fraction being divided by h. What I'm thinking about doing here is getting a common denominator. And I'm going to do that carefully. If I've got the square root of x plus h in one denominator and the square root of x in the other denominator, my common denominator is going to be found, I'm going to multiply by square root of x plus h over square root of x plus h over there. Square root of x over the square root of x over here. And let's see where that gets us. Limit as h approaches 0. Square root of x times 1 is square root of x. Minus 1 times the square root of x plus h. Square root of x plus h. They have the same denominator now. I know that because I built it that way. This is going to be square root of x times the square root of x plus h. This whole fraction is being divided by h. And what I want to do to make my life a little bit easier, if I have this whole fraction divided by h, keep it, change it, flip it. That means instead of dividing the big fraction by h, it's the same as multiplying by 1 over h, which will put an h there in the denominator. I know I went a little fast there on the algebra. Let's see what happens now. If h goes to 0, I've got square root of x minus square root of x. That's 0. 0, square root of x, square root of x plus 0. I've got 0 in the numerator, 0 in the denominator. We know that. Indeterminate form. I know. I need a better marker. Great. I have all the blacks to pick from. Okay. All right, 0 over 0. Let's try something clever. For all the friends that are working right now, if you finish the one that you picked, pick another one. Square root of x minus square root of x plus h, and I'm seeing this in an indeterminate form. How about if I multiply by the conjugate? The square root of x plus the square root of x plus h over square root of x plus the square root of x plus h. Take the limit as h approaches 0. When I multiply the numerator, we've done this a lot, you probably know what's going to happen. Square root of x times square root of x is x minus square root of x plus h times the square root of x plus h is x plus h. Don't forget the parentheses. If you really want to be complete, square root of x times square root of x is x. Square root of x times square root of x plus h. Negative square root of x plus h times square root of x. Guess what? They cancel, which is why we get over here. Now I've got h square root of x plus h times square root of x plus the square root of x plus h. Let's do a little bit of fancy algebra here. x minus this x, they cancel, leaving me a negative h in the numerator. Fortunately, I've got an h in the denominator, so this h can factor cancel with that h in the denominator, leaving me, the limit as h approaches 0, negative 1, square root of x times the square root of x plus h times the square root of x plus the square root of x plus h. If I take the limit as h approaches 0, negative 1 in the numerator doesn't change. Square root of x doesn't change. X plus h, this guy gets close to 0, leaving me just an x. This guy gets close to 0, leaving me just an x. If I clean it up, I've got negative 1, square root of x, times the square root of x, square root of x plus the square root of x is 2 square roots of x. Let's clean it up a little bit more. Square root of x and square root of x is x. I'm going to get negative 1 over 2x square root of x. There it is. That's the final answer, and I look forward to checking in with all the friends in about 1 minute. Alright. So sad that it's time to erase all the beautiful work. Alrighty, friends. We can pull everybody back together here. Okay, first one, 3x squared minus 5x plus pi. Did anybody do this one? The first one? No, that's right, because I only had a couple people that picked number 2. Okay, number 1, the derivative should be that f prime of x is equal to 6x minus 5. Okay, I'm not going to tell you why yet. If you know the shortcut, that's fine, but what you were just doing for the last couple of minutes was the long way. We are developing your notation, annoying little brother. I mean, your practice with the annoying little brother. Not that you are an annoying little brother. I never heard that from Elizabeth. No. All right, number 2, x cubed plus x minus 1 should be 3x squared plus 1. Who actually did that one by hand? Did it come out to be 3x squared plus 1?
Yes.
For those of you that know a shortcut, did that fit?
Yeah.
Good. So you have not been lied to. Okay, number 3. Who had number 3? Somebody had number 3. What'd you get, Paloma?
4x.
Okay, did you actually multiply it all out and get 4x to the third? Because there is no way on that little, like, one line of work. The goal here was for you to get the practice that you need. Number 4, who had square root of x? What'd you get?
1 over 2 root x.
1 over 2 root x. Indeed, I agree. Who had number 5? 1 over x. Yes, ma'am.
Negative 1 over x squared.
Negative 1 over x squared. I agree. Number 6, Stephen, you did 1 over x squared, right?
Yeah.
Did you get a derivative?
Yes. Negative 2 over x cubed.
Negative 2 over x cubed. I love it. And number 7, my beautiful work led me to, what did I say? Negative 1 over 2x times the square root of x. Okay. Here's just by a show of hands, how many guys honestly were able to work through the problem that you picked without the shortcuts? Okay, good. Now here's the thing. The shortcuts are coming. They are beautiful. They have arrived. I just got them off Amazon Prime this morning. Okay, we are going to get to start using them today. But what I need you to understand, what the College Board is going to expect you to hold in your mega brains here, is that when you're actually being asked to find a derivative, you are using one of these three. This is the thing. This is where Newton made his mark. Newton didn't make his mark by coming up with shortcuts. It was this big conceptual idea of, if I have slope of a tangent line at a point, I pick a second point, let the points get closer, 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 closer. All these shortcuts that we're about to come up with are a result of the definition. Are you okay with this? Here's what Noah's going to happen. For all 11 of you and all the friends watching at home, you're just going to memorize the shortcuts. Some of you've already memorized the shortcuts. That's fine, that's great, but I want to make sure that we have a deep understanding of where they came from, because that's what we're going to build off of. All right, so I have delayed the shortcuts for as long as I can. Here they are. And I'm going to ask you to get up on your feet for a couple of these. The first one is called the power rule. Let me tell you what the power rule says. It says if f of x equals x to the n is your exponent, right? Mm-hmm. Then f prime of x, you guys know what that is, that's the derivative, is found by, the derivative is n times x to the n minus 1. The power rule basically says, take that exponent, what are we going to do? You're going to do two things. It's a two-step process. Step 1, bring the power down. Step 2, subtract 1 from the exponent. Everybody okay? This is the power rule. Okay, so say it with me. The power rule says, if I have x, to a power, we bring the power down. And reduce the power by 1. All right, one more time. Think like Arnold Schwarzenegger, angry Austrian fellow. The power rule says, if we have x, raised to a power, what do? Bring the power down. Reduce the power by 1. This is the power rule. You get to use it forever. So for example, the derivative of x to the 100th, no one wants to do, I would argue probably no one on the planet has ever done the definition of the derivative x plus h to the 100th. What do we know? What do you guys all know the derivative here is?
100x to the 99.
I see x to the power of 100. The power rule says, bring the power down, and then what?
Subtract 1.
Reduce the power by 1. 100 times x to the 99. That easy. That really is okay. It's okay. All right, let's look at some more challenging ones though. How about if f of x is 1 over x squared? Is this x to a power?
See. Yes.
How many see this as x to a power? Meaning, like, you're not seeing 1 over x squared, you're seeing x to a power because you know something about exponents. Polymon, what do you know?
Since the x is underneath, that just means that the original is going to be a negative.
Right, 1 over x squared is the exact same thing as saying, and this is where I want to be careful with the notation, f of x equals x to what power?
Negative.
X to the negative 2 power. I am not, and here's where I'm going to get wicked picky. This is the new picky place for me. This is not the derivative. This is rewriting the original function. Now, this notation tells me something. It tells me something important. What's it telling me to do?
Take the derivative.
That this guy here is one of our many ways to write derivatives. So because we're still kind of brand new here, I'm going to use a different color. So what's the derivative of x to the negative 2? What does the power rule say? Power rule says, bring the power down, and then reduce the power by 1. Now be careful here. Bring the power down, reduce that power by 1. Negative 2 times x to the negative 3rd. And as much as I like that as an answer, the better answer looks like negative 2 over x cubed. Now I'm curious, One of you had, don't worry about that. One of you actually found the derivative of 1 over x squared. Steven, you did 1 over x squared?
Yes.
Did you get that as your answer?
Yes.
So this fits, right? I have some evidence that the rules, the shortcuts that you're aware of, are not made up things. Good. All right, how about this one? Have a conversation with somebody near you. Example 3, is this x to a power?
Yes.
If so, rewrite it and find the derivative. But I want to see, Aaron, this is where I'm coming for you. I want to see that you're rewriting it first. Don't just write x to the half floating out there in space somewhere. J of x equals x to the half. Aaron, what's the derivative going to be? We've got x to a power, right? What does that power rule say?
Bring the power down.
Bring that power down. And then?
And then you subtract and reduce the power by 1.
Reduce the power by 1. So 1/2, reduce that by 1. What are we going to get?
3 halves.
One more time.
No.
Reduce by 1. Subtract.
Oh, negative 1/2.
Right, 1/2 minus 1. We're really saying that was a good joke for a fake Monday. 1/2 x to the negative half power. I like this answer. There's a better one out there. Who sees the better answer? Use those exponent rules. What do you, I see Polymon, I see Celeste. Hoping for some friends on this side of the room. What's a better way to write this? David.
1 over 2x. No, 2 square root of x.
1 over 2 square roots of x. Explain to me how you get there. You're right, but how'd you get there?
So the exponent is negative, so I'll do the bring it down.
The exponent is negative, that says put it down in the denominator.
And then 1 over 2 is square root of x.
If the exponent is 1/2, that means I'm actually taking the square root of x. Is everybody okay? Does this fit? Is this the derivative we were expecting? Absolutely. All right, one last one here. Find d over dx of x. Still derivative. Andrew, do you see this as x to a power? You do? What's the power? Right, x is really x to the 1 power. So let's find that derivative. That says bring the power down, reduce the power by 1. So 1 times x to the 0. Good answer, I want better. Everybody wants 1. Power rule, everybody good? Power rule, this is the one. This is the big one. And usually like the AB students are going to struggle with problems like 1 over x squared. They're going to be like, oh, the derivative is 1 over 2x. No. The power rule works if you have x to a power, Square root of x, you're going to have to rewrite x to a power. If you ever need help with the exponent rules, they're all over there on that side of the room. Way conveniently written, way too small for you to see them in the middle of a test. All right, we got a couple more coming your way. Here we go. We've got constant rules. There are 2 different rules that we consider the constant rule for derivatives. Oh, I just erased part of the H. Don't tell Mr. Link, he'll never know. All right, constant rules. Okay, Carmen wants to be able to sit next to the exponents, apparently. All right, first is that the derivative of a constant is 0. Constants aren't changing. If I asked you to like graph a constant, right, the function is horizontal, the slope has to be 0. So it is true that the derivative of a constant is 0. However, if you have a constant times a function, this is one I want to make a big deal about. Constant times a function. Then the derivative is going to be found by just leaving the constant alone times the derivative of the function. Just leave that constant alone if it's multiplication. You already know this, trust me. All right, say it with me. The derivative of a constant is 0.
The derivative of a constant is 0.
However,
However,
the derivative of a constant times a function
the derivative of a constant times a function
is equal to the constant times the derivative of the function.
is equal to the constant times the derivative of the function.
Oh, that was a little bit awkward there at the end. Let's do it one more time. Okay, the derivative of a constant is 0.
The derivative of a constant is 0.
However, the derivative of a constant
The derivative of a constant
times a function
times a function
is equal to the constant
is equal to the constant
Times the derivative of the function.
Times the derivative of the function.
Love it. Okay, so let's look at this one. All right, so example number 5, f of x equals 3x squared. Is that a constant? No. No. This term here, 3x squared, is not a constant. If think about the graph, what does that graph look like?
It looks like x squared with the triangle.
3x squared, is that a constant? It's a parabola. So this is an example of a constant times a function. What the rule says is, if you're taking the derivative of a constant times a function, leave the constant alone, take the derivative of the function. And the derivative of the function is 2x. So we get 6x. Everybody okay? All right, so let's push a little bit more. F of x equals 5x to the 12th power. Find f, what the heck?
That looks like you.
Prime.
F,
Wait, so what
okay. So some people call this f prime prime. Other people call it second derivative. Other people call it f double prime. Choose one, it does not matter to me, although f prime prime, people are going to giggle at you when you go out to college. Okay. Have a strategy conversation with somebody near you, what are you going to do? Trust your instincts here.
So you do the prime. So you do the prime and then you do the prime of that.
You said 60x.
That's the derivative.
Oh, we're doing it twice.
I'm assuming.
Okay, except if I want f prime prime, what are we going to do?
Examples of how to pronounce it.
Okay, so what it looks to me like you're finding the derivative one time already.
Times 11 is 6.
So f prime equals 5 times 12x to the, what's the power?
That makes sense.
Times 10 and then set another
X to the
Oh, I just did 11 times 16.
Alright, walking around, I saw this on a lot of papers. F prime, ignore that 5, derivative of x to the 12th should be 12, x to the 11th, even better, 60x to the 11th power. Everybody good? F prime prime, F double prime, Aaron, what do you have for me with F double prime?
60.
60. Aaron.
Oh, to the 10. Oh, I thought you were.
Okay, I heard 60, that's all I heard.
60x to the 10.
60x to the 10th, I don't agree with
Oh,
you.
times.
660.
660.
60 times, take the derivative of x to the 11th.
We're at 660, right?
Alright, right, so it's going to be, first step would be like 11x to the 10th power. Bring that power down, reduce the power by 1,
660.
and multiply it carefully, 660x to the 10th. How many guys honestly had 660x to the 10th? We get this under control. Okay, last two rules, I always put them together as a pair. They're called the sum and difference rules, just meaning it's how you're going to handle finding the sum and the derivative of a sum or a difference. If I have two functions being added together, the sum rule says, trust your instincts, find the derivatives, add them together. If it's a subtraction problem, find the derivatives, subtract them from each other. So let's do this first one. F of x equals x cubed plus x minus 1. Find f prime of negative 1. So f prime of negative 1, it's two steps. First, find f prime of x. Second, evaluate at x equals negative 1. Okay, so take a second. Go find f prime for me. Derivative of x cubed is what, 3x squared? Plus the derivative of x? 1. Minus the derivative of 1?
So
Derivative of 1, 1's a constant. It is a constant all by itself, 0. So that's f prime of x. Now, next move, show me f prime of negative 1. 3 times negative 1 squared plus 1 is 4. Pretty good? Good. Alright, next one. F of t equals t to the 8th plus t squared plus e. Find f prime of negative 1. Well, that's not very exciting. be careful with your variables here. F prime of t, derivative of t to the 8th is 8t to the 7th plus the derivative of t squared, 2t, plus the derivative of e. E, is that a variable?
Yes. No.
Or is it a constant?
That's a constant.
It's a constant. Just like pi is a constant, pi is 3.14159, blah, 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 blah. E is 2.71828 and some more. Oh, and it's also on the number line up there? Yeah, that's why Carmen has left you all. 8 times negative 1 to the 7th plus 2 times negative 1. I don't really care what this answer is, but I think it's going to be negative 10. Okay. Okay. All right, there were some sample problems on the next page that, if you guys are okay with this, we are going to skip, because what I'd like to do is use the last 12 minutes to let you guys get started on the corrections process. Okay, especially with this being the first time. All the derivative rules that we just talked about are fair game, meaning you get to use them all the time now. Unless the problem says you can't. And I will be very clear about when you cannot. Okay? Stop staring at me like that, you're creeping me out. Because you're so pretty.
Thank you.
Not at all. Okay. All right. So there are a handful of problems that I think we should talk about whole group. Problem number 3 is one worth our talking about. Number 6, number 8, 3, 6, 8. I think that's it on the multiple choice. 7. See, now you're just tricking me into like doing all your homework.
No, we really.
14.
14.
14?
Yeah.
Okay. All right, let's talk about number 3. Okay. So if you got, oh yeah, we need to stop filming at this point. And it's not because I don't trust the North Central kids, but I don't want this video with all these worked out problems floating around out there when the AB kids haven't